My name is Alphan Uzun. I'm an electrical engineering student at Bilkent University. Today I'll be presenting you my Physics 102 project, testing Kirchhoff's rules in RC and DC circuits. Main goal of this experiment is to try Kirchhoff's loop and junction rule in different experimental settings to see whether if it can be used for circuit analysis in practical manner. In part A, the aim is to observe the idea of junctions in a DC circuit. In order to achieve this goal, circuit in figure D is set up with the instructed materials in the equipment part. In the experiment, currents coming through and getting out of junction B is observed with the multimeter connected in series in between points AB, BC, BD separately. Results are noted in table 1. Then, results are compared to the theoretical value of Kirchhoff's junction rule, and the error value is added to the table 1. Same steps are applied to the junction D, but this time current values between BC, BD, DE is observed through multimeter, and results are noted in table 2. In part B, the aim is to observe the idea of loops in a DC circuit. To reach this goal, again circuit in figure D is set with the instructed materials. In the experiment, each loop is observed, thus starting from loop 1, potential difference between all the circuit elements is measured with multimeter connected in parallel, and results are noted to table 3. Comparison of theoretical values and experimental results is given with an error margin in the same table. Afterwards, same steps are applied to the circuit elements of loop 2 and 3, recording the data on table 3 and 4 respectively. Now that the Kirchhoff's laws were observed in the stable current DC circuits in part A and B, part C's purpose is to observe Kirchhoff's law in changing current setup of an RC circuit. For this reason, circuit in figure E is set with a discharge capacitor. Firstly, junction rule is tested with a similar multimeter setup in part A to measure I1, I2, I3, and I4 over time with the goal of observing junction B and D. Current values for I1, I2, I3, and I4 are noted with 5-second intervals for 30 seconds, and data will be displayed on table 7 and graph 1. Comparison of theory and experimental results is calculated every 5 seconds, and in the end a mean error value is found, which is noted in table 7. Secondly, loop rule will be tested with a similar multimeter setup to part B, measuring potential difference over circuit elements. Voltage values is noted in 5-second intervals for 30 seconds. Data is displayed on table 8 and graph 2. Comparison of the theory and experimental results is calculated every 5 seconds. And in the end, a mean error value is found, which is noted in table 8. As for result discussion, Kirchhoff's law for predicting part A and B's results were expected to be stable and reliable as voltage and current of the systems observed were constant. Results fulfilled the expectations. Junction rule for DC circuits holds relatively true for junction B and D in part A, with an error percentage of 7.69 and 4 respectively. Also from part B, it can be seen that Kirchhoff's loop rule holds true for a DC circuit in the observed loops 1, 2, and 3, with an error percentage 1.71, 0.08, and 2.63 respectively. While looking at the results of part C, it can be seen that capacitance part of the circuit acted like an open circuit while it was discharged, and as time progressed, resistor connected in parallel to capacitance received more current, proving even in non-constant voltage or currents, Kirchhoff's law can still be utilized. In part C, junctions B and D were found accountable to the theory with 1.32 error percentage in both junctions. For loop rule, loop 1 and 2 were found to have 1.13 and 3.02 error margins respectively. These errors in data may have occurred due to some of the following reasons. Friction and resistance of the connecting cables was not put into consideration. Capacitance may not have been fully discharged. There can be a possible induced current while the circuits are being turned on. And lastly, values presented in the data part was rounded to 2 significant figures, which may have been the reasons for the found errors.